So welcome to lab 3, or I will say lesson 3 of learn JavaScript object-oriented programming concepts. So in the first lab we talked about what are JavaScript objects. In the second lab we talked about something called as prototype. Now in this lab or in this lesson we will talk about something called as JavaScript closures. So in this 16 minutes of video, what I will do is I will first talk about the basic concept of JavaScript closures, and then in the remaining part of the video we will talk about how JavaScript closures helps you to implement proper object-oriented programming concept in JavaScript language. If I put a simple definition around closures, then we can say closures are nothing but they are stateful functions. I again repeat, closures are nothing but they are stateful functions. Means what? When you create a function in JavaScript, by default it is stateless. Means, for example, now let us say I create a function here called as counter, and let us say I create a variable inside this function called as counter, and I increment this variable, and let's say I put a simple alert. So now if we go and call this function over here, so let us say if I call the function, this is the first time I'm calling him, this is the second time I'm calling him, right, second time. And now if I run this, so you will see that, so I've done a control F5. So this is the first call, it shows 1. If I click again, this is the second call, it shows 1. So in short, this call of the counter has a different state than this call of the counter. Now if you think fundamentally, this is absolutely right, because when a function or a method runs, it creates a running memory. So all these variables like counter, etc., they get created on a running memory called as a stack. So the counter variable gets allocated on the stack, it gets incremented, displayed, and then released. So it happens for the first time. Then again, when we run for the second time, a new running memory is created, right? And the first one is then disallocated. So basically on stack, when any variable is created, the function is executed, the variable is created, and then released. But now a lot of times what happens is we want that the function and the variables should stay in the memory, right? For example, I want that every time I call this counter, I want this value to get incremented. So in other words, I want this variable to be remembered. Now, one of the things which can come to your mind is that you can say that, okay, then why don't you do like this? Why don't you go and create a variable globally? Like if you do this, this should solve the purpose, right? So example, if I run this now, you can see that the variable is created globally on the browser. So it's 1 and then 2. So what is the problem with this approach of creating the variables globally? Now, one of the rule of good programming is that modules, functions, methods, they should be self-contained. They should be isolated, self-contained modules. So if you're going to have such kind of global variables and they are accessed by this counter function, we can have problems. For example, think about if there is some other function here called as my counter. Now he is also going and incrementing the same variable, then we can have unwanted errors or unwanted defects, I will say, right? So basically when you talk about modular programming, we want that the module should be self-contained, they should be isolated, they should be a single unit. So in other words, I would like that this variable should be private over here, right? And it should have a different instance altogether. And that's where exactly closures comes into picture. So closures help you to achieve isolated, stateful functions. So to write a closure is nothing but it is a function inside a function. So in other words, that's why the name closure, because one function encloses another function. So now let us say I will go and create a method here called as increment, right? A function here called as increment, and in this I will go and I will put this and increment, and this method I will return back, right? I will talk about this return function, this return thing here. But you can see now a closure is nothing but it is a function inside a function. So this function is enclosed, that's why the name closure, enclosed inside other function, right? So now what I can do here is I can go and say here where x is equal to counter and then x dot increment. Again, I can go and create a different instance or a different isolated memory. So here also I can go and say now where x1. So now you can see here what I'm doing is this is the first time I'm calling and this is the second time. Now both of them are different isolated memory, right? So if you see now here it should show the value 1 and here it should show the value 2, right? And here it should show the value 1 because this is a different instance, right? So if I do a control F5, 1, 2, and the second, this is the second instance, again 1. So you can see now here in every call he is remembering the local variable. But now the question comes, so in reality when we are doing projects, what is the use of such isolated stateful functions or closures? So if I put in one single sentence, closures helps you to implement object-oriented programming concept in JavaScript in a very, very neat way. So let me go ahead and let me demonstrate you how closures help you to achieve that. So what I'm going to do is I'm going to go and cut this code out here and I will paste it right down below so that you can see them later on. So I'm going to go and put this as a comment here so that you can see this code later on, right? Because this code of counter was only to make you understand the basic concept of closure. Now let me go and talk about how can we use these stateful functions to create proper objects, or implement proper object-oriented programming in JavaScript. Now if you see some of the principles of object-oriented programming is, the first one is abstraction. Abstraction says that show only what is necessary. Second principle is encapsulation, which says hide complexity. And then we have something called as inheritance, parent-child relationship, and then we have something called as polymorphism, which says that depending on situations the object will behave differently. So depending on situations, different behavior. So now the question comes is that, okay, so how are these principles implemented by closures? So first thing, let us start with abstraction and encapsulation. So now let us say I want to go and create a customer object. In this customer object, I have some properties. So I'll say, okay, I have the customer name property. I can have customer code property. I can have some validate function and so on. Also, let us say I have one function here which says DB connect. This connects to database and get some data, right? So in the validate method, probably I am calling the DB connect first, and then I'm doing some validations. Now by default, what I've done is I have made all the things private. In other words, I have implemented encapsulation. Means whatever is the complexity, I have just hidden it. Now what abstraction says? Abstraction says show only what is necessary. So what is needed to be shown to the end user? I have to show him the customer name property. I have to show him customer code. I have to show him validate method, but I don't want to show him the DB connect method because this is encapsulated. I don't want the person who is consuming my component to connect to DB, right? It's something done internally by the validate function. So what I will do now, I will implement abstraction. So in other words, here I will say in the return what I want from these four things to be public. So I will say I want the customer name to be public. Now when I am making things public, I would like to call them with some user-friendly names. For example, internally this is underscore customer name, but from outside I want people to call it by customer name. So customer name, when anybody sets a property to customer name or value to customer name, internally it will store it in underscore customer name. In the same way, I will say if anybody calls to customer code, internally it will set to customer code. In the same way, if anybody will call validate, internally it will call validate. So this is abstraction, show only what is necessary. You can see in this return, I have not given DB connect. So in other words, DB connect cannot be called from outside, right? So you can see because of closures, I can implement proper object-oriented programming concept. And because this is a closure, this is a self-contained object. It's an isolated object that makes it a very, very good module, right? So I have a customer object here. These are the private things and these are public, or I will say these are abstraction which I want the developer who is consuming my component to know about it. So now here what I can do is I can just put an alert here. I'll say this is validate. So now I can go and start using my self-contained customer object. So my self-contained customer object is clean. It is not confusing with the global variables, right? It is completely isolated. So I can say here now where cust is equal to new customer, and I can set properties like cust dot customer code is equal to 1001. I can set the name. I can call validate. So you can see now we have a very beautiful object here which is following abstraction, encapsulation. It is self-contained, right? And that is the beauty of closures. So I'm going to go and run this to just check if this works. So you can see this is validate is running, right? Good. And to implement inheritance, what we need to do is, which I already discussed in the previous part of the video, we need to go and just set the prototype object. So if you remember, we had this prototype object, we can use that, right? So for abstraction, encapsulation, we are going to go and use closures. So this is implemented by closures. This is implemented by closures. And this is implemented by prototype. So you can see like you can really go and do proper object-oriented programming in JavaScript, right? Now about polymorphism. Polymorphism, as it says that depending on situations, the object should change the behavior. Now JavaScript is a dynamic language, so there isn't any polymorphism, or I'll say rather there is always polymorphism, right? Because it is dynamic, any variable can become of any data type. So I can just go and say where cust is equal to new customer. So this points to the parent, right, at some moment of time, and the same customer can now point towards customer child. So really, like when you talk about polymorphism in JavaScript, it is by default the behavior of JavaScript. So you can see, because of closures, because of that self-contained function which is tied up to an environment at that time, right, we are able to achieve proper object-oriented programming concept. So let us quickly revise what we have learned. So closure is nothing but it is a function inside a function. So this is the customer and this underscore validate is the closure inside it. Closures are nothing but they are isolated stateful functions, and because of that we can go and implement abstraction, we can go and implement encapsulation, we can implement proper object-oriented programming concepts using closures. So I hope that you enjoyed this video. In this video we were trying to understand what exactly are closures. In the next video I'm going to go and discuss about a very, very important thing called as immediately invoked function expression, IFE. Because I feel that when you talk about good object-oriented programming, one of the things is that you want to go and put your components into modules. Like in C# and Java, we have something called as namespaces. So in the next video, I will talk about how immediately invoked function expression, IFE, helps you to implement namespaces in JavaScript. Thank you very much.